is. Now, all of you, and could you just pay attention, because I can't see you or hear you. All of you can plot a beautiful curve. Occasionally you might get the wrong coordinates, one or two places, but I can obviously highlight that for you. The reason I wanted you to do this one is so you can appreciate what having these extra x squared does amongst an x cubed graph. And it gives you one little hump, two little humps, as opposed to a beautiful, smooth, S-shaped curve going from left to right. So I wanted you to appreciate what an extra x squared can do. Besides, it's practicing plotting in any case, isn't it? So that's not a bad thing. And well done to you who did it without a calculator, because that's exactly what you shouldn't use, unless it gets too much. This one's really easy. This just to show that this graph of x cubed is transformed one unit up in the y-axis. So as you can see, it's slightly lifted off the 0, 0, because the 0, 1 right there. But this was the point of the question, actually. Show that when x is 1.5, you can get a solution of y equals 5. And some of you didn't go like that, and you should have done, because that's called showing your evidence. That gets you a mark, quite apart from saying y equals 5. If you're a little bit out, it doesn't matter, as long as you're honest with your own graph. Why is this one here? Well, I actually calculated these, longhand. So you plot the graph, done, from -4 to 4, and you get this graph here. And too many of you didn't read this. The whole point of doing this graph is to find the solutions where y equals x cubed minus 5x equals y equals 0. In other words, you need to find along the x-axis where this lovely curve cuts through. And on my demo, I've pointed to here, here, and here. Approximately, on my one that is, minus 2.2, 0, and 2.2. But too many of you just did the graph and ran on. So you really need to watch that, because that's the whole point of this question. This one has a point as well. Like I told Hamza a couple lessons ago, it's a negative x cubed graph, so it starts to face the other way. But again, the point really of this is to solve this equation, not just to plot a graph. You can all plot graphs. You can see this graph matches x minus 2, so you've got to draw the straight line graph of y equals x minus 2. So I don't know, I made a couple of coordinates. I chose x to be 0, so y is minus 2. I chose x to be 3, so 3 minus 2 is 1. I just made two coordinates, that's all I did, and I plotted them, and I drew my line, y equals x minus 2. And then you've got to solve it. That means find the x values. If I just pick up my graphics pen, there she is, that's what I mark with. If you can just look there, where they cross, read up there. Where this crosses, read up there, roughly minus 0.4, 2 squares. And this one is almost 3, or 2.9. But that's what it wanted. It wanted solutions. In other words, find the x values. Getting dry now. What's the point of this one? Well, this is the big one. This is the big one. Yep, you can all plot that beautiful. And it's quite a difficult graph to plot, I have to admit. But you've got to solve this. And this is what we did in class when we were matching quadratic equations with another quadratic equation they wanted us to solve, and we solved it by plotting one straight line rather than plotting all this again from scratch. No, that's not economical. That won't get you a grade 7 or an 8. So here's the original graph, and here's the graph they want us to solve. So instead of making a whole load of table of values for this, we just use the one we've done before and do a comparison. How do you get from minus 5x to minus 4x? Answer, you plus 1x. So all you have to do is to draw in the line y equals x. And if you do that, you get three solutions. One about there, minus 2.6, one about there, minus a half, and one about there, x equals 2. All right? So that's what you needed to do to get a grade 7 or maybe 7 plus or an 8. So let me just ditch that, and you will notice that with this lesson I've introduced the next set of graphs, the next style of graph. It's called a reciprocal graph. These are the 1 over x types. Now I'm going to scribble on mine. I've got loads of copies anyway online. So this is a reciprocal graph. It's based on 1 over x. And clearly, if you go 1 over x times 2, you end up with 2 over x. The style of the graph is quite unmistakable. It's shocking. And let me show you what it looks like. I'll put that on question 4. It's the last thing I studied. Yeah, that's the graph of 2 over x. 2 divided by all these x values, 2 divided by 0.25 is basically 2 divided by a quarter, which is 8. 2 divided by 0.4 is like saying 20 over 4, and that goes in 5 times, etc. So I actually worked these out without a machine when I originally did this. Look at the style of the graph that you get. Look at that. They do not even join. They do not join. Look at this. This statement, 2 over x will never equal to 0. The graph approaches the x-axis, but never, ever actually touches it. The x-axis is called an asymptote. That's an A-level word for those of you who will be doing A-level, and some of you will. In the same way, over here, 2 over x will never reach infinity up there. You know, after 80 is 8 billion, and after 8 billion, there's 28 billion, etc. It will never touch that axis at all. And so it will never reach infinity. That's called, so both the x-axis and the y-axis is called an asymptote. Why does it do that? Well, let me scribble on my sheet, and I'll tell you why. If you just look at y equals something over x, if you try and put 0 inside that, you're saying, what is 2 divided by nothing? Now, nothing, you know, is a very, very small number. In fact, it's so small, it isn't a number. So how many times does nothing go into 2? Answer, billions and billions and billions and billions. It heads towards infinity. That is why it gets closer and closer to the y-axis without ever touching it. All right? So that's what the first one will look like. And don't be tempted to join the ends. They don't touch. They shoot off in different directions. So here's the next graph, minus 1 over x. So it will look like 1 over x, but minus. What does that even look like? Well, let me give you a heads up on what it looks like. Instead of looking like that, and if you calculate it correctly, you know, you usually calculate if you're desperate, it will look like that. So what was over here has come over here, and what was over here on this side has come over here. If I just make it smaller, there we go, maybe you can see that better. So what was something like that now looks something like that, okay? I've got to make it bigger, just a bit. All right, so that's that one. Here's the next one. Again, this is what it should look like, and I try to keep my brain with me by not uploading all the workings as I did last time. But anyway, good luck to you. Now they want you to do 4 over x, and they give you a ready-made grid. Go 4 divided by 0.2, which is 440 over 2, which is 20. Yes, 20 in there. And they give you a lovely grid later on. Then they want you to use your graph to solve this. Now, clearly, if we've got y equals 4 over x, and that equals to 4 minus x, don't be confused. All they want you to do is to plot the line y equals 4 minus x, or if you prefer, minus x, add on 4. Just make a couple of values, just 2, and then you get a lovely straight line. In fact, you should do a third one, because if you've made no mistake with your straight line, it will be a straight line. If one of those 3 points is out of line with the other 2, then maybe one of those points is wrong. So you can self-check. Then they set you another question. Draw this one. Oh, lovely. Okay, so here's the grid for the first one, the first question. And here's the grid for the second one. I don't know if I did this one. I got bored after a couple of questions. Let's take a look, shall we? So that's my calculations. And it looks like that. This time it actually does cross the y-axis. I think this little 4 here and this minus 1 has got a lot to explain for itself. So that's why we don't get asymptotes there. And I realised the grid that they gave us doesn't actually allow you to plot 0.2, 20. So that one I just crossed off originally when I did it. Again, I worked these out in my head. It's not difficult. And again, the other one, minus 0.2 and minus 20, that's never going to work. So here's what I said before. We know y equals 4 minus x, that little bit. Make some coordinates, I made a couple. It will look a little bit like that. So that's the original graph of 4 over x. And this is the graph of y equals 4 minus x. I plotted 1 point there and 1 up there. And it sort of just about touches it in one place. Doesn't touch this. This goes off in a different direction. It does touch it there. So it implies that this line is a tangent touching at 1 point. So it looks like my solution is x equals 2, because 2.5 is about there. So 2 is about there. Again, it's only an approximate solution. And I definitely did not do question 2 because it was a bit long. I didn't bother plotting that. I'd had enough. So you don't have to do it either. And guys, that's all I need you to do. Now, this is the situation. When we do corrections like this, like this rather, where is it? That one. I'm not asking you to print all this off, yeah, and throw your original work away. I just want you to make some additional notes how to improve your work. And the stuff that I mark and send back to you, don't go printing that off. It's going to cost you paper, which is cheap, but cartridges and toner, no, you can't even get that stuff now. It's difficult. Just make corrections to your original graphs, which you can rub out clearly. Plus, remember, this is being recorded, I believe, I hope. And that being the case, you can leisurely go onto YouTube, because I always send you the link to our videos lesson, all right? And just take it from there nice and slowly and make corrections. But don't go printing off all over again. Please don't do that. So let me just stop sharing and therefore stop the video at this point.